Hi everyone, welcome to Unit 16 of online course on probability distributions. In the last module, we have discussed some numerical examples related with binomial distributions. That is, we have obtained probabilities of certain events. That is a case of applying binomial distribution in different fields. In this module, we are again going to discuss some numerical problems related with the binomial distribution. So, if you are given a binomial random variable, that random variable is governed by or the model of the probability mass function is decided by the values of the parameters n and p. That is, suppose we have a random variable x that follows binomial with a parameter n and p, then probability of that random variable, probability mass function of that random variable is given by ncx p power x q power n minus x, where x is a random variable having the values 0, 1, 2, etc. up to n, and p and q are satisfying the equation p plus q is equal to 1. So, this is the binomial probability mass function. Suppose you are given some equations or some parameter value, the quantities mean, variance, etc. of the binomial distribution. Can you find the parameter value? Can you find the values of n and p? That is a problem for us. So, in this module, we are discussing some problems like that. That is, suppose you are consider a problem. Suppose you are having a binomial distribution with a parameter value n is equal to 6, and that random variable satisfies an equation 9 into probability of x is equal to 4 is equal to probability of x is equal to 2, and find the probability of success p. So, this is an example of a problem where the binomial distribution is mentioned, but the parameter value, that is the parameter of n and p, both are not given to you. If it is, how do you find the parameter value? Here the first parameter n is equal to 6 is given to you. In order to find the parameter, second parameter p, you are given an equation. So, consider that problem. That is, suppose you are given n is equal to 6 and another equation is given 9 into probability of x is equal to 4, 9 into probability of x is equal to 4 is equal to probability of x is equal to. This is given to you. See, the problem is, suppose you are given x is a binomial random variable with the parameters n and p, where the parameter value n is given to you. How do you find the value of p? That is a problem. And for that, what we are doing here, see this equation, you just convert that equation in terms of probability mass function. So, 9 into probability of x is equal to 4. Already we have probability of x is equal to x. We have the value ncx p power x q power n minus x, we know. That is the probability mass function. And using that value, here it is n is equal to 6c4, p power x, p is unknown to you. So, p power 4 and q is, you know, it is 1 minus p, power n minus x, n minus x is 6 minus 4, is equal to probability of x is equal to, that is probability of x is equal to means 6c2 p square 1 minus p all power 4. See, that is the given equation is converted in terms of probability mass function of the binomial distribution. So, 9 into 16c4, 6c4 p power 4 into 1 minus p the whole square is equal to 6c2 p square 1 minus p the whole power 4. And that is simplified. You have 9 into 6c4, you know, it is equal to 15 p power 4 1 minus p the whole square. Again 6c2, that is 6c2 means 6 factorial divided by 6 minus 2 factorial into 2 factorial. That is again 6c2 is equal to 15 again, because 6c4 and 6c2 are same. So, 15 p square into 1 minus p power 4. Simplifying, the common factors are cancelled. So, this becomes 9 into 15 will be cancelled, on p square, here it is p square, and is equal to 1 minus p the whole square. So, the equation, given equation reduces to 9 p square is equal to 1 minus p the whole square. That is 9 p square is equal to 1 minus p the whole square. 9 p square is equal to 1 minus p the whole square. That is equal to 1 minus 2p plus p square. So, that is 8p square plus 2p minus 1 is equal to 0. So, you can find the value of p. P is equal to minus 2 plus or minus root of p square minus 4ac, that is 30 plus 32 divided by 2a 16, or that is equal to minus 2 plus or minus root of 36, that is 6 divided by 16, and that is equal to minus 4 by 16 and 4 by, sorry, minus, sorry, 4 by 16. And p is a probability value that never become negative. So, the value of p is equal to 4 by 16, or that is 1 by 4. So, for the given problem, that is, you are given n is equal to 6, we obtain p is equal to 1 by 6 using the equation that is given in terms of x. So, this is a general problem of a binomial distribution. Suppose some quantities are given to you, that is, suppose the one parameter value is given, or some probability equation is given, or suppose mean is given, variance is given. How do you find the parameter values of the distribution? Here this is a question where n is equal to 6 is given to you, and a probability equation, that is 9 into probability of x is equal to 4 is equal to probability of x is equal to 2 is given to you, and the value is equal to p is, we are finding the value p, and p is equal to, sorry, this is actually 1 by 4, sorry, 1 by, so 1 by, the value is equal to 1 by 4, p is equal to 1 by 4. So, that is a problem of binomial distribution for finding the parameters. Similar to this, another question we are considering, that is a question again the similar nature. You are given a binomial distribution, and here what are given to you? You are given that mean of the distribution is 5 divided by 2, and the probability of x is equal to 1 is 5 by 32. And the question is find the variance of the distribution. Here also the same situation, that is you are given a random variable x that follows binomial distribution and its mean value is given to you. And how do you find the variance of the distribution if probability of x is equal to 1 is equal to 5 by 32 is given to you? So basically here also the question is, so x is a binomial random variable, you are given x is a binomial random variable, and you are given mean is equal to, mean of the random variable is equal to 5 by 2, 5 divided by 2 is given to you, and another thing is probability of x is equal to 1 is equal to, this is probability of x is equal to 1 is equal to 5 by 32, 5 divided by 32 is given. So if these two values are given, what is the variance of the random variable? The question is this one. Suppose x is a random variable having the parameters n and p, and suppose you are given mean is equal to 5 divided by 2 and probability of x is equal to 1 is 5 divided by 32. What is the variance of the distribution? How do you find the variance? And you know, for a binomial distribution, variance is equal to what? Variance is equal to, the expression of the variance is NPQ. So variance is equal to NPQ. And if n is p and q values are available, or n and p are available, you can find the variance. And how do you find? See, you are given mean is equal to 5 by 2. What is expression for mean? Mean is equal to NP. For a binomial random variable, mean is equal to NP. So you are given actually NP is equal to 5 by 2. Okay, that is the first expression, that is mean is equal to 5 divided by 2 is nothing but NP is equal to 5 divided by 2. And second expression, what is the second expression? Probability of x is equal to 1 is equal to 5 divided by 32. And probability of x is equal to 1 means probability of x is equal to x for a binomial random variable. The general expression is NCX p power x q power n minus x. This is the general expression. So that is probability of x is equal to 1. That is probability of x is equal to 1 means NC1 n p power 1 q power n minus 1, 5 divided by 30. So these are the two equations given to you, that is NP is equal to 5 divided by 2 and NP q power n minus 1 is equal to 5 divided by 32. How do you find the value of this? So just consider these two equations. You have, this is actually 5 by 2 q power n minus 1 is equal to 5 divided by 32, because this NP value is substituted as 5 by 2, and that is equal to q power n minus 1, q power n minus 1 is equal to 1 by 16. So that is, you have q power n minus 1 is equal to 1 divided by 60. See, q power n minus 1 is equal to 1 divided by 16. And what is this one? This is actually, you can write this as 1 by 2 power 4. That way you can write. So q is a value in between 0 and 1. It is a probability value. So that is, n is an integer, 0, 1, 2, 3, etc. Considering these two aspects, consider, and this equation give us q is equal to 1 by 2 and n is equal to 5. So, n minus 1 is 4, so n is equal to 5. So, n is equal to 5 and q is equal to 1 by 2. And hence, what is the variance? Variance is equal to npq, that is 5 into 1 by 2, that is p is 1 by 2, q is also 1 by 2, or that is 5 divided by 4. So, the question is to find the variance of the binomial distribution if you are given one expression that is regarding mean and another expression that is with regard to a probability values. So, solving these two expressions, solving these two equations, you will get the parameter values, and the values of n and p are obtained. Using the values of n and p, we are calculating the variance, whatever be the quantities required in the case of the binomial distribution. So, this is a problem like this. So, again another problem you are considering here. Suppose for a binomial distribution you have consisting of 5 independent trials, probability of getting 1 and 2 success are given as 0.4096 and 0.2048 respectively. Find the parameter of the distribution. So, this is also a problem similar to the earlier one, that is for a binomial distribution consisting of 5 independent trials, probabilities of 1 and 2 successes are given as 0.4096 and 0.2048 respectively. Find the parameter p of the distribution. So, the question is to find the value of the parameter. One of the parameters, that is n, is given to you. So, consider this, that is you are given x is a binomial random variable, x is a binomial random variable, and given n is equal to 5, and the another thing you are given the statement, that is the statement is what? The probabilities of 1 and 2 successes are, these are the values given to you. Probabilities of one success is 0.4096, and so probability of one success, that is x is equal to 1, is equal to 0.4096, okay, and probability of 2 successes is 0.2048. Probability of 2 successes 0.2048. See, so a question like this. Suppose x is a binomial random variable with parameters n and p. One parameter value n is given to you as 5, and in order to find the second parameter, that is p value, you are given an equation in terms of the random variable. So, this is again you know the probability of x is equal to x, that is our NCX, p power x, q power n minus x is our general expression. On the basis of that general expression, this equation converted to probability of x is equal to 1, that is n p q power n minus 1, that is a probability of x is equal to 1, that is equal to 0.4096. Okay. So, first equation, probability of x is equal to 1 is equal to 0.4096 is same as n p q power n minus 1 is equal to 0.4096. Similarly, probability of x is equal to 2, that is x is equal to 2 means nc2, that is n into n minus 1 divided by 2 p square q power n minus 2 is equal to 0.2096. 048. Okay. And see, you are given n is equal to 5, that is given to you. So, the first equation, the first one, this equation reduces to np, that is 5p q power n minus 1 is equal to 0.4096. And suppose this is the second equation we have, and you substitute n is equal to 5, the second equation reduces to n into n minus 1, that is 20, 5 into 4 divided by 2, that is a 10, p square q power n minus 2 is equal to 0.2048. So, the given two equations are 5 into pq power n minus 1 is equal to 0.4096 and 10 p square q power n minus 2 is equal to 0.2048. And these two equations, solving these two equations, you will get the value of the parameter value p. And how do you solve this equation? Suppose you have the left hand side, just you consider left hand side 10 p square q power n minus 2 divided by 5 p q power n minus 1, that is actually 10 p square q power 10 p square q power. So, see here also I have mistake, we have not substituted for n here. So, just think this is equal to 4, and here also you have to substitute n, that is 3. So, that is 10 p square 48 and 5 p q power 4 is equal to 0.4096. These are the two equations we have. And solving this is 2 p divided by q is equal to 1 by 2. So, this left hand side and right hand side are considered, and simplifying 10 p square q cube divided by 5 p q power 4, that is 2 p, 1 p is remaining and divided by q is the value. So, that is p divided by q is equal to 1 by 4, that is p in 4p is equal to 1 q, that is 1 minus p. So, 5p is equal to 1, that implies p is equal to 1 by 5. Okay. So, that is you are given n is equal to 5 and two equations you are given to you, and if it is, how do you find the parameter value p? And to get the parameter value, we simplified the equations, and solving the equations, we have the value p is equal to 1 by 5. Okay. We are considering a problem, that is a problem of the binomial distribution with respect to moment generative function. See, suppose x is a random variable with a moment generative function mxt is equal to 1 divided by 216 5 plus e power t or power 3, that is find the value of probability of x is greater than 1. So, this is a question related with you are given the moment generative function, and from the moment generative function can you find the probability of x greater than 1, or can you find the variance, can you find the mean, can you find the probability of x is equal to probability of certain other events, etc. And since x is a random variable having this moment generative function, this moment generative function has a peculiarity. That is, for a binomial random variable, we have already established the moment generative function. The moment generative function as mxt is equal to q plus p e power t all power n. See, this is our moment generative function of the binomial random variable. Let me write. So, suppose x is a binomial random variable, then the moment generative function of this binomial random variable is equal to q plus p e power t or power n. And what is given to you? You are given that x is a random variable having the moment generative function mxt. The problem, you are given that mxt is equal to 100 divided by 216 and 5 plus e power t or power 3. This is the moment generative function given to you. Can you express this function as in the form of this, very similar to this one? Because you can see this can be written as 5 plus e power t divided by 6 or power 3. This way you can write. Because 216, that means 6 power 3, or that can be again expressed as 5 by 6 plus 1 by 6 e power t or power 3. Okay. So, given moment generative function mxt, that is 1 divided by 216, 5 plus e power t or power 3, can be represented of the form 5 divided by 6 plus 1 divided by 6 e power t or power 3, which is of the form, this is similar to this. See, just look, q plus p e power t or power n form, where comparing these two functions, can see q is equal to 5 divided by 6 and p is equal to 1 divided by 6 and n is equal to 3. And remember, p plus q is equal to 1, then only that is satisfied. So, mxt, that is 5 by 6 plus 1 by 6 e power t or power 3, is similar to q plus p e power t or power n, which is the moment generative function of the binomial random variable. And by the uniqueness property of the moment generative function, that is, we can identify the distribution on the basis of the moment generative function. Since this is the moment generative function of a binomial random variable having the parameters n is equal to 3 and p is equal to 1 by 6, you can conclude that the random variable given to you as nothing but binomial with n is equal to 3 and p is equal to 1 by 6. So, this is our problem. That is, we have x is a binomial with 3 and 1 by 6. So, suppose if you are given the moment generative function, that is 1 divided by 216, 5 plus e power t or power 3 is given to you, then we derived that x is a binomial with parameters 3 and 1 by 6. After that, you can answer any question related with the random variable. Suppose the question is to find the problem here, it is find the probability of x greater than 1. The question is this one. Find the probability of x greater than 1. What is probability of x greater than 1? That is nothing but 1 minus probability of x is equal to 0 by taking the complement part of the random variable. Because x is a random variable having the values 0, 1, 2, 3, etc. So x greater than 1 means it is 1 minus probability of x is equal to 0 and 1. Sorry, again x is equal to 0 and 1. X, it is greater than 1. Probability of x greater than 1. So that is 1 minus probability of x is equal to 0 plus probability of x is equal to 1. And that is simplified 1 minus probability of x is equal to 0. What is probability of x is equal to 0? We have probability of x is equal to x. If this is the binomial random variable, we have 3cx 1 by 6 power x 5 by 6 power 3 minus x. If this is the binomial random variable, the probability mass function is this one. Substitute here, it is 5 by 6 power 3 plus probability of x is equal to 1 means 3 into 1 by 6 into 5 by 6, the odd square. So, suppose probability of x greater than 1 is required, then the value is equal to 1 minus 5 by 6 or power 3 power plus 3 into 1 by 6, 5 by 6 the whole square. Simplify the expression, you will get the probability. So, the question is very simple here, that is, if you are given the moment generative function, you identify that moment generative function as a moment generative function of a binomial random variable, and that equated to the moment generative function of the binomial random variable, that is q plus p e power t or power n. From that expression, you can find the value of the parameters n and p, and if the parameter values are known to you, you can find the probability of any event, or you can find the variance, you can find the measure of skewness, you can find the measure of kurtosis, etc. So, that is a problem of the binomial distribution if you are given the moment generative function. Next, we consider another problem, that is a problem using the properties of the characterization of the binomial random variable. Suppose x is a binomial random variable with 6 and 1 by 3 as the parameters, and y is another binomial random variable with 4 and 1 by 3 as parameters, and they are independent random variables. If it is, can you find the probability of x plus y is equal to 3, or can you find the mean and variance of x plus y, like that. That is, here we are applying the property of the binomial distribution, that is the additive property. What is the additive property? The additive property, suppose x is a binomial random variable with the parameter n1 and p, and y is another binomial random variable with the parameters n2 and p. See, p is common, okay, and they are independent. These are independent random variables. You are given x and y are independent. By the additive property of the binomial random variables, this is x plus y follows binomial with n1 plus n2 and p. So, this is additive property of the binomial random variable. And the question, this is an application of the additive property. So, what is given? X is a binomial with 6 and 1 by 3, and y is a binomial with 4 and 1 by 3, and they are independent. So, what we can write? X plus y is a binomial with the 6 plus 4, that is 10, and the parameter, second parameter 1 by 3. So, this is an application of the additive property. That is, suppose you are given x and y as the binomial random variables with these parameters, then x plus y is a binomial random variable with a parameter n is equal to the number of trials 10 and probability of getting success 1 by 3. Then remaining aspect we can find very easily. What is the remaining probability of? So remember, you are given x plus y follows binomial with 10 and 1 by 3 is the result we obtained. Now the question is find the probability of x plus y is equal to 3. Find the probability of x plus y is equal to 3. Probability of x plus y is equal to 3 means what? It is 10 C3 p power 3, that is 1 by 3 power 3, and q, that is 2 by 3 power 10 minus x, that is 7. Because here n is equal to 10 and p is equal to 1 by 3, and hence q is equal to 1 minus 1 p, that is 2 by 3. So that is probability of x plus y is equal to 3. And just look, what is another quantity required? Mean and variance of x plus y. What is the mean and variance of x plus y? Mean is equal to mean of x plus y. Our original from the binomial case, we know the mean is equal to np. For a binomial random variable with parameters n and p, mean is equal to np, and this is equal to n is here 10. N is equal to 10 and p is equal to 1 by 3, 10 by 3. And similarly, variance of x plus y. Suppose you are finding variance of x plus y, the expression is npq. Npq is equal to 10 into 1 by 3 into 2 by 3. So it is 10 divided by 3, and this is 20 divided by 9. So this is a problem actually. We are answering this problem on the basis of or applying the additive property of the binomial distribution. Like this, we can find any quantities if you are given that x and y are two independent binomial random variables with the parameters n1p and n2p respectively. You can find probabilities or quantities, mean, variance, measure of skewness, measure of kurtosis, etc. of x plus y random variable using this application of additive property. Okay. So like similar problems we can work out corresponding to binomial distribution if the parameter values are available. So we will discuss some more problems in the next session. With this, we wind up this session. Thank you for hearing this session. Thank you to all.